Okay, today we're looking at function tables. These are also called input-output tables, just depends on the context that you're looking at them. What we see here is a table. It's got an X column and a Y column. Your X column is often called the input, and your Y column is the output. What we're going to try to do is write an equation based on the information that we see in the column. So, first we need to figure out a relationship between the X and the Y. We're going to try and see, looking at the X column, how does it become the number in the Y column? So, in my first set, I have 0 and 0. I know I can't add anything to 0 to get a 0, nor can I subtract it. So I'm probably going to be dealing with multiplication to turn my X column into the Y column, but let's keep looking. I know I could add 2 to 1 to get 3, so it might be plus 2. But if I add 2 to 2, I do not get 6, so it's not going to be plus 2. Let's go back to the multiplication thing. 1 times 3 would give me 3. 2 times 3 would give me 6. 3 times 3 is 9. 4 times 3 is 12. So it looks like the number in the X column times 3 would equal the number in the Y column. So my equation would be the X column times 3 equals the Y column. Okay, so let's look at a couple other tables. In this table I have my X and my Y column. The top two are 0, so I can't tell a lot from that. If I look at the next row, I have 2 and 8. I know that I can go from 2 to 8 by adding 6. So let's go down a row and check. 4 plus 6 would be 10, so that's not going to work. How else can I get from 2 to 8? I know that I can multiply by 4. 2 times 4 is 8. 4 times 4 is 16. 6 times 4 is 24. 8 times 4 is 32, and 10 times 4 is 40. So it looks like the rule and the equation I would write would be that the X column times 4 would equal the Y column. My next one, my X's and my Y's, the first row is actually not zeros. I go from 0 to 4. Well, 0 times anything is going to be 0, so that would not give me a Y. 0 minus something would be negative. 0 divided by something isn't going to work, so I'm probably adding here. 0 plus 4 will give me 4. 1 plus 4 would give me 5. 2 plus 4 is 6. 3 plus 4 is 7. 4 plus 4 is 8. So it looks like my X column plus 4 would equal my Y column. My last one, this one actually has labels for my X and Y, weeks and kilograms. So my 2 needs to turn into a 1. I know I could do that by subtracting. 2 minus 1 gives me 1. 4 minus 1 would give me 3, so that's not going to work. What else makes a number get smaller? I could divide. 2 divided by 2 would give me 1. 4 divided by 2 would give me 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. So it looks like my X column divided by 2 would equal my Y column. Let's look at something different. Here we have a word problem. Berger's 6th graders are trying to fundraise money for their DC field trip. The student council decided to sell boxes of chocolate bars. Each bar sells for $1.50 and each box contains 20 bars. Below is a partial table of money collected for different numbers of boxes sold. So let's look at the things that I have filled in over here. I have 1 box of chocolate was $30 and 5 boxes of chocolate was $150. Well, I can go from 1 to 30 by adding 29, but 5 plus 29 is not 150. Most likely what I'm going to be doing is multiplying. 1 times 30 gives me 30, and 5 times 30 would give me 150. So the next thing I'm going to do is just fill in my chart. 2 times 30 would be 60. 3 times 30 is 90. 4 times 30, 120. This is just like doing ratio tables that we did earlier in the school year. 6 times 30 is 180. 7 times 30 is 210. And 8 times 30 is 240. So now I have a completed input-output table. The graph. Remember on a graph that the side-to-side numbers are your x coordinates and the up and downs are your y coordinates. So we just need to graph the numbers that we see in our chart. It makes sense too because it's labeled here 1, 2, 3, 4, 5, and these are the small numbers in the x column. And then these are larger numbers 50, 100, 150 that matches up with my y column. So my x is 1, here's a 1, and my money should be 30, so I'm going to go up to about where 30 would be, which was right here. 2 and 60, so here's my 2, go up to about where 60 would be. 3 and 90 should be just shy of 100. 4 and 120 be about here. 5 and 130 be just under 150. Oh, sorry. 5 is 150 right here. 6 and 180. 7 and 210. And 8 and 240. One thing that will always happen with these function tables right now is that they should make a nice straight line. The last thing that we want to do is figure out our equation. So our boxes of chocolate and our money. Instead of X and Y, they have it being B and M, boxes and money, but it works just the same way. My column, my boxes of money, and we decided that you had to multiply each box times 30, and that would equal how much money you get. All right, last problem. This one looks like I need to look at this graph and use it to fill in my table. So remembering that my horizontal or my side to side is my X and my up and down or my vertical is my Y, let's fill in the chart. Right here I have a dot. The X coordinate, I've gone over 5 and I've gone up 0. My next one, I've gone over 10 and I've gone up 5. So over is X is 10 and up 5. My next dot is at 15 over, so 15, and it's up, lines up with the 10. My next one is over 20 and up 15. And my last one is over 25, and it looks like it is up 20. So I went backwards there. I used my graph, and I read what the dots were, and I filled in my table. So now let's see if we can write an equation based on our table. I need to go from a 5 to a 0. Well, I can divide 5 by 5 to get 1. I think I'm going to have to use subtraction here. 10 divided by 2 gives me 5, but 5 divided by 2 does not give me 0. So I can subtract 5 minus 5 to get 0. 10 minus 5 would give me 5. 15 minus 5 is 10. 20 minus 5 is 15. 25 minus 5 is 20. So it looks like in order to get my equation, my x column minus 5 would give me my y column. So that gives you all the information you really need to know about your function tables or input-output tables. Now you can practice on your own. If you have questions about what you're doing, come back and watch the video again.